Next speaker. He started marine biology in Peniche, Portugal. He has always been involved in research on the effects of marine protected areas, the effects of, yes, the positive effects, of course. He has a background in aquariology as well, in the Baltimore Aquarium first, then in the Sea Life Center. Today, he is science officer for Flying Sharks and also marine biodiversity specialist in the task group for the extension of the Portuguese continental shelf. Please welcome Mr. Nuno Rodrigues.
Okay, so good morning, everyone. Thank you, Stefan. As Stefan said, I'm the Flying Sharks science officer. Most people see Flying Sharks as a collection and transport animal company. That's just a little bit of what we do on our day-to-day routine. We are also actively involved in science, in research, and we do this in two different ways, either by supporting people and institutions doing research, or directly funding this research in different projects that are happening worldwide. So the way we support financially our these people and institutions is through the Flying Sharks Research Fund. Some of you may already contributed to this fund if you got any of our services. This started in 2008, and we started adding voluntary contribution to all of our services, and this money goes directly to fund several projects. So we've raised so far a total of around 35,000 euros, and we're supporting many different projects and events, and these are only a few of them. I'm going to talk a little bit of a few projects that we've directly sponsored, and we think we're some cool ones. You can see on the right top bottom, there's a logo, and this logo is from the institution who directly subsidized this specific project. So, for example, Project 1, Ana Sequeira, Portuguese young lady, she wanted to study real sharks, whale sharks in Australia, and she was having a lot of difficulty to be funded to do this research. She got, however, 4 grants in 2010 after a long battle, and Flying Sharks bought her plane ticket. So her PhD is based on investigations of behavioral ecology of whale sharks in Australia. She's trying to understand which environmental variables may affect whale sharks' distribution. She came to these results where sea surface temperature is a key component for whale shark distribution, and that large shifts in current aggregation locations are to be expected under upcoming climate change scenarios. So on the bottom you see the institution that sponsored Ana Sequeira, and Flying Sharks also one of them. So this is a nice story to tell everyone in the aquarium. Project 2, Helena Zalena. She's this girl who wanted to study the abundance size and population structure of white-tip reef sharks in Costa Rica. She's using tag and recapture techniques, but also underwater visual counts. We helped Helena with some of the equipment she needed for her research. Her results show that these white-tip reef sharks do not have a defined spatial ontogenetic segregation, since both juveniles and adults are found in the same sites. And that white-tip sharks use specific resident sites. She estimated a population of around 400 individuals. She's still working with sharks, and she, along with a local government, they created the Mission Tubarão, shark mission, and she's working actively in this population of white-tip reef sharks. Project 3, İsmet Saygu. He's a Turkish researcher. He wanted to quantify bycatches of skates in Turkish commercial trawling fishery. It also had the objective of determining survival of discarded animals. He's completed his master's thesis, and is now working on his PhD. His work is slowly turning him into the leading shark guy in Turkey, and he mostly focuses his research on discards, which are a very important story to tell. André Afonso, he's a Portuguese young man working in northeast Brazil, in Recife, which is now considered the shark capital, the shark attack capital of the world. Pretty scary news out there regarding the shark attack in Recife. He's studying the movement patterns of tiger sharks of northeastern Brazil, and the tiger sharks' movements and their interaction with the humans. Valentina Di Santo, she's doing her PhD in Boston, and she's focused on ecophysiological responses of fish to increase ocean acidification and warming. She focused on research on early life stages, as environmental stress might be more pronounced in these phases, causing a bottleneck effect in wild populations. So climate change, of course, is the last ultimate story to tell to our visitors. Ximena Velho Suazo, she wanted to study hammerhead sharks and to identify critical areas for juvenile hammerhead sharks in northern Peru through assessment of shark fisheries. That's a scary image, but sadly common in North Peru. The smooth hammerhead is the third most fished shark in Peru, and national reports suggest that the hammerhead fishery is dominated by juveniles. The data obtained from January to April this year suggests that Peru might be an important reproductive and nursery ground for this kind of shark. In January, most of the landings were newborns, so that's definitely something we should think about, and well, scary stuff. Now, this is actually the three last projects I'm focusing on are basically research we supported, not just financially, but also we were together doing research with these guys. The first one is Luis Silva. He's been a Flying Sharks member since day one. He's now part of all of our operations. He's working in our brand new facility. That's one we'll present afterwards in the Azores. He's also working on his master's thesis, and that's actually what I'm about to present right now. So he's focusing on the collection, ascension, and acclimation of Anthias anthias, the swallowtail sea perch. These animals are collected at 40-45 meter deep of Fayal in the Azores, and he tested. They have usually problems with decompression. The decompression stages have to be followed, otherwise they can have barotrauma issues. So he tested multiple ascension rates. You can see a chart here, basically represents what Luis has been doing. There's a dead weight on bottom, and there's a buoy on top, on surface, and there's buckets. He collected the animals and slowly ascended these animals in different, testing different ways of doing it. So once the anthers are collected, they are placed in these buckets, and they're raised over days, often. He tested multiple ascension protocols from 15 to 20, 35, and 45 reduction in pressure, and he tested over 12 hours in 24-hour steps. I'm not going to go through these charts, but I've got all the information with me, or João's got all the information too, so feel free to come to us and we'll share gladly these results. So he came to the conclusion, which was kind of what we expected, that the 15% ascension rate had the best results and had the highest proportion of neutral animals. And the same for the 24-hour stops for each depth was also achieved the better results for the proportion for neutral animals. So he came to this decompression profile that suggested might be the best, so you can have really good results in the lowest or shortest time possible. And so 35% for the 24 hours, 35% of the pressure decrease in the first step, 24 hours, from 30 meters to 16 meters. Again, 35% for the second step, 12 hours from 16 to 7 meters, and 25% for 24 hours in the two subsequent steps, from 7 to 3 and from 3 meters to the surface. Project 8, Hugo, Tiago, Rui, and Bruno. These are young researchers from Peniche, local facility where both me and João work and where we keep most of our animals. So they were trying to test, they were maximizing bioloads in sealed transports while ensuring survivorship. So this was their final graduation project. We tested 4 different local species, Lepadogaster, Lipophis folis, Gobis paganellus, and Diplodocharcus. So these are all local species and are commonly found around Peniche waters. So the methods, they bagging increasing bioloads and checking at 24 hours, 48 hours, and 72 hours afterwards. We monitored ammonia, pH, oxygen, and of course, percentage of survival. So the results is that they were helping us with this because we've been shipping these animals to a lot of institutions, and we came to the conclusion that we were being way too conservative regarding bioloads. So we were using far smaller bioloads than actually this species can handle safely. Again, I'm not going to go through these charts, but just so that you know, we're using about 10 grams per liter in Lepadogaster, and we came to the conclusion that 30 grams per liter would be acceptable. The 40 grams per liter would result in degree of, the oxygen rate would be too low after 72 hours. So we realized we can go the triple that we were using before, ensuring 100% survival. For Lipophis foliage, the shani, we were using 10 grams per liter, and we realized we can go actually to 20, the double, for these animals, and they will do perfectly after 72 hours. Gobis paganellus, this is the only species we actually realized that we're using more or less the right bioload, because once we increased only about 2.5 grams, the oxygen rate dropped considerably, especially after 72 hours. Of course, 72 hours is probably too much for any transport to anywhere in the world, but this is just, if anything happens, it's just stuck in the airport. It happens in the boxes, so 72 hours was our limit. For Diplodocharcus, we concluded again that we were using 1.25 grams per liter, and we could actually increase it to the double, and we will have good results and 100% survival rates. So, in conclusion, these are cool and thoughtful experimental designs that allowed us to conclude that we can pack much higher and safe bioloads than before, thus saving money for our clients and assuring still 100% survival. Project 9, Monica and Sarah, they've been rearing and, well, they got the eggs from us and they clothed the eggs and reared Sepia officinalis, cuttlefish. and they were choosing the most appropriate diet in order to maximize growth rate. So they tried 3 distinct diets: live mysis shrimp, live hepalette, which is a small local shrimp that can be collected in tide pools in Peniche, and frozen mussels. What they realized, and that's pretty much what we know already, that the live mysis worked great and they had a fast growth. The hepalite was not as good, and the growth rate was not as good. And frozen mussels are definitely not one of the options. We ended up having almost no growth, and the animals ended up dying. So Project 9, Hugo, he's doing his master's degree with flying sharks, and he's focusing on different themes: the collection and husbandry of new species, namely fish, and the clinkfish, the lepidogaster, egg eclosion, and rearing. There's Hugo. So the new fish, we're mostly focusing on some deep water animals that are collecting usually under 100 meter deep. So these are 4 of the species where Hugo is working on with our help: Helicolenus dactylopterus, the black belly rosefish. We've dated already, so you can see in one of our tanks the animal, and we have shipped to some of you these animals. Pontinus culi, we're almost there. We got a pretty much good idea of how to do it, but we're still struggling with the Beryx splendens and Beryx dactylactyls. These are beautiful animals, and we're eager to try to get them, well, alive to the surface and improve all the husbandry protocols. So lepidogaster, who did it already. He got the male and female, got the eggs, the eclosion occurred, and the animals are now about 3 or 4 months old, and they're doing good. So in conclusion, research makes sense, of course. Sharing the results of research with the public is extremely important, and research enhances husbandry techniques and animal well-being. Therefore, supporting research makes sense. Thank you very much.
Thank you so much, Nuno. Any questions?
On Project 8, with the oxygen assessment during packing, did you subject the boxes to any sort of mechanical agitation to simulate transport, or were they actually transported, or were they kind of just left and sat?
Well, that's a really good question. No, the boxes were left and no agitation, but that's actually something we thought of. Just like, for example, just put it in the car and just walk around, drive around and see the effects of that. That's a good question, yeah.
Thank you.
You're welcome.
I've just got a question about the Amphius one. Previously, when you were collecting Amphius, were you always having problems every single time you bring them up?
Well, we've researched a little bit on Anthias collection, and from the first attempts, we knew that we had to do it slowly and following different, several steps. So he tested bring them to the surface. That was the control animals, and he brought them immediately to the surface. And of course, those animals had a lot of issues, and they were brought back to the dip and just do the thing in all the normal steps, and that worked. So yeah, all animals, or I would say 95% of the animals would have problems if we didn't do it. Yeah.
I was just wondering what the depth is that you start getting the problems from.
Oh, okay.
As well, sorry.
They were closed in these barrels, so we only realized the problems on the surface.
Yeah, okay.
Yeah.
Thanks.
Thank you so much, Nuno.
Okay, everybody, good morning. Thank you for